In this exercise, I'm going to show you how to configure IPsec, and we do have a packet tracer file. This time, I've configured pretty much everything: IP addresses on PCs, on routers, routing. I have some static routes here. We should be able to have all the needed communication between these PCs. As you can see on this diagram, we need to establish IPsec between these two networks, so between 192.168.1 and 192.168.3. We will be setting up VPN on router 1 and on router 3, and router 2 will not even be aware that there's any tunnel going on across this network right here. So let's get going. The first thing we need to do is we need to check if a security technology package is active. This is kind of a license on router 1 and router 3. As I said, router 2 will not be aware of what's going on, so we don't really need to configure anything related to IPsec on router 2. In order to check this, we need to type in show version, and then I'm gonna press space. This is the package we're looking for. Obviously, it's not here, so it's not enabled. We don't have the license for that, so we need to activate that license. Also, what I want to know is the version of this module. It's C1900. You'll see why I'm looking at that. Okay, how to activate this module? You need to get into global configuration mode and then type this command: license boot module C1900 technology package, and then the name of that license is security K9. Yes, this is like the terms of use of this license. Okay, and it tells me here that I have to reboot, but first I want to save the configuration. As you know, the configuration is going to go away when you reboot if you don't save it. So I'm going to say do copy running config to startup config. And that's it. And now I'm going to go back to this privileged mode and I'm going to say reload. Okay. While that is going on, I'm going to open router 3 and do the exact same thing on router 3. Of course, I know that I don't have that license, so I'm just going to skip that part and go straight for that command where I activate the license. So the command is license boot module C1900 technology package security K9. Yes, and then exit, and then I'm going to say copy running config to startup config, enter, and then I'm going to say reload. Yep. I'm going to start configuring IPsec on router 1, and the first thing I want to do here is to create an access list which will define which traffic exactly needs to go through this tunnel. So we want to send only the packets going from this network to this network through the tunnel. I don't want to use IPsec when sending data from here to here. So I only want the packets going from this network to this network to go through the tunnel. I'm going to say that in an access list I'm going to create. So I'm going to say access list 110, that's an extended access list because I need to specify both the source and the destination. And I'm going to say permit IP. You will see later I'm going to use this number 110, that's the access list, later on during IPsec configuration. But for now, just bear with me. 168.1.0 and then wildcard 000.255, and then destination is 192.168.30 000.255. And we'll just leave that list at that. The next thing we want to start configuring is called ISAKMP phase 1 configuration. In this phase, these two routers negotiate the terms of further communication, or otherwise known as SA. SA stands for Security Association, and it represents kind of establishment of shared security attributes between two networks to support secure communication. And I don't want to get too much into theory here, but an SA includes, they're called attributes, whoops. And those attributes are cryptographic algorithm, traffic encryption key, and other parameters for the network or the connection. And ISAKMP stands for Internet Security Association and Key Management Protocol. But enough with the theory. I promise to show you how to configure this in practice, so let's get going with that. The first thing I'm going to do here, I'm going to say crypto ISAKMP policy 10. Okay, 10 is policy priority. You could have several policies on one router. Actually, it's probable that you will have several policies, and number 1 would be the highest priority. This way you're telling your router how to negotiate with the other side. It should push for the highest priority policy, but the success of this depends on what the other side prioritizes as well. In this exercise, we will be configuring both routers, so we can only create one policy, or it is enough for us to create one policy. We could create several policies, but we will survive with only creating one policy, and that one policy will be the same on both sides. So there's no need to worry about negotiations. Next, I'm going to say encryption, AAS. Here we're choosing the encryption algorithm. Supported algorithms are, as you can see, AAS 3, DES, and DES. And DES isn't recommended anymore by Cisco, so we're going to use AAS. Authentication pre-share. Pre-share is for pre-shared key, also known as pre-shared secret, and this means that the two sides will exchange the keys before they start the communication. Next, I'm going to say group 2. This is actually the default, and it's a Diffie-Hellman group, and each group is for a different strength of the key. It doesn't tell the number of bits. If I can remember well, group 1 is 668. I know for sure that group 2 uses 1024 bits, and group 5 uses 1536 bits. We're going to use group 2, and that's it for the ISAKMP policy. Now what we want to do is we want to say crypto ISAKMP key, and this is the pre-shared key I was talking about. So Cisco is going to be the word, the key, and then I'm going to say 10 to 1. Let me check that to be 100% sure. That should be the IP address of router 3. That's this address right here. Yes, 10.2.2.1. I was right. Great. I think we need to say address here. That's right. Okay. And this is where the first phase ends and the second phase begins. In this phase, the routers are communicating according to the terms agreed in phase 1, and they're now negotiating the parameters of the actual communicate, so the network traffic that's going to go through that tunnel. And the first thing to do is to say, okay, I'm going to type in the command first and then I'm going to explain it. Crypto IPsec transform set, and this is the name, so this is the string, you can say whatever. I'm gonna name it VPN set, and I'm gonna say ESP3DES. Here we're obviously choosing some protocols and encryption algorithms and hashing, and I'm about to explain that, just hold on. And I'm gonna say SHA HMAC. No errors, thank God. Okay, this command defines a so-called transform set, which is a combination of cryptographic algorithms and hashes. I mentioned a moment ago that 3DES isn't recommended anymore, but let's use it here for example's sake. And then SHA HMAC is the chosen hash, but ESP might be a new thing for you, so let me explain. ESP is short for Encapsulating Security Payload. It's a protocol that provides confidentiality, data integrity, authentication, a couple of other things, but you should know that there's another option here. It's called AH, short for Authentication Header. And while there are differences between these two, the most important one to remember is that AH, authentication, authenticates the entire IP packet, including the outer IP header, while the ESP authentication mechanism authenticates only the IP datagram portion. So the names pretty much say it all. This is a really quick explanation, though. Please research more for real life use in a real network, because your routers or a firewall, wherever you are configuring this, might only support one option, for example. So yeah, you should definitely research that before deciding on what to use. Next, I'm going to create a crypto map. And this is a name, again, VPN map 10 IPsec ISAKMP. This new crypto map will remain disabled, la 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 la. Okay, I've already configured an access list, so we're cool here. Here we are creating a crypto map, and number 10 here as well is a priority, and VPN map is a name, so you could have called it whatever. And you'll see later how we'll use this to tie all of these parameters to an interface. And then you can use description. You can type in whatever you want here. You can say VPN connection to router 3, for example. Next, I'm going to say set peer. This is obvious, 10, 2, 2, 1. That's the other end of the tunnel. And then I'm going to say set transform set, VPN set. I'm connecting that transform set we created earlier to this crypto map. I have a typo. That's it. And here, finally, I include that access list that we created earlier. I'm going to say match address, and this pretty much means that all IPs permitted in that ACL should go through this IPsec tunnel we're configuring right here. And the only thing left to do is to connect all of this to the interface, and we're going to do that like this: interface serial 000. That's the interface which the packets have to go through to get to this other network with which we want to establish VPN. So I'm going to say interface serial 000 and then crypto map VPN map, and that's it. I mean, that's it for router 1. Now we need to do it all over again on router 3. And I'm not gonna, because this is already a 15-minute long exercise, I'm going to just configure it without many explanations. It's pretty much the same. You'll see the commands are the same. Everything is the same. I'm going to use the same hash algorithms, encryption algorithms, etc. And the only thing that's going to differ is the IP address. So this time my peer is going to be router 1, and on router 1 I always said my peer is router 3, so the IP address is going to be different, and that's it. Here I have to create the access list again. I'm going to name it the same, permit IP, and it's just switched. So this time it's going to be from 192.168.3.0 to 192.168.2.10. Okay. This is important. We need to have the same key here. That should be it. We want to first test if the communication can happen. It can. And now I want to check what happens with the packet. Usually if you configure something wrong with IPsec, it's not even going to work. So the ping doesn't work at all. Yeah, this resolution thing is kind of an issue, but let me... Okay, I got it. So we want to get to router 1 first, and we should see, oops, we should see, now we're okay. All right. We should see the difference between inbound PDU and outbound PDU. You will see even here this traffic is interesting traffic and needs to be encrypted and encapsulated in IPsec. The packet is getting encrypted and encapsulated in IPsec PDUs. ESP encrypts the received packet, blah, blah, blah. An IPsec message is sending out of serial 000. And then if you look at inbound PDU details, you'll just see your usual stuff. While here on the outbound, because that's where this packet gets encrypted really, because on this interface, it's still the original packet that this PC sent out. But on this interface, it's already going through the tunnel. So we have this HDLC frame, IP, and then we have this ESP header data. And then if we, one second, if we checked on router 2, router 2 doesn't really know or care what's going on in here, because you can see that this ESP header is inserted after the IP header, and all the information that router 2 needs in order to route this packet further is this header right here. So it has the source IP and it has the destination IP. That's enough for this router to maybe check if there's some access list maybe for these parameters. But since there's not, and it has a routing table in which it has a route to 10.1.1.0, this is actually this outside address over here, and not this network over here, it sends that packet toward router 3, and then router 3 knows that this packet is a part of this tunnel thanks to that access list that we set up. So yeah, that's pretty much it on IPsec. I hope you found that useful, and I think I might create only one more exercise for this course. So see you in the next exercise.